Okay, we are getting ready to go here. I'm just gonna let Kayla get on real quick. Hi, Kayla. Kayla, I just put the link to the Nearpod in the chat box.
Hi.
Hi. And then for everybody, if you want just to have it with you so you can follow along, I just put in the link for the PowerPoint. Okay, so if you want to open up the PowerPoint so you can see the information on the PowerPoint, and follow along, and then you can look back at it when I ask the questions. It's there for you. That might help you with answering the questions. So we'll just wait just a second more. Let's let Kayla get onto Nearpod, and then we'll get started. We're listening to the 80s party mix today. This is Queen. Did anybody see the movie that had Queen in it? That was about Queen. That was a great movie. I can't remember the name of it. What was the name of it? Does anybody remember? It's very well done. It ends with him at the AIDS concert, like rocking everybody on. Anybody watch it? It was about Queen. Bohemian Rhapsody. Yes, thank you, Ethan. Did you like it? I thought it was really good. Oh, you should watch it. No, you didn't watch it either. Yeah, it's a good movie. You know what else was good? Was the one with Elton John. Yeah, I don't remember the name of the Elton John movies, but that one was really good because if you like Elton John music. Okay. All right, let's get started. So the first thing that we are talking about today is we are starting off with our ice-breaking question, and it is, what is something that brings you joy? And I'll explain why I asked this in just a second, but let's just see some of your answers. So we have food, which I totally understand. That's a very good one. Puppies and kittens are always very helpful, and especially when you can give them back, especially puppies, because puppies can be a lot of work. Sleep. Love me some sleep. I gotta tell you, this morning I did not want to get out. I wanted to go back to sleep. I can completely get that. Getting a pinnacle, Destiny 2. Can you explain this to me? What is this? Made in heaven is under. Can anyone explain that to me? I don't know what it is. Is it a computer?
A really rare thing to get in a video game.
What video game?
Destiny 2.
Oh, that's the name of the video game. I'll ask my son about it because he plays a lot of video games. Nice. Thank you, Ethan, for sharing that. And then we have music, which obviously I love music. Okay. That's something that I totally dig, obviously, if I'm playing it all the time for you guys. Okay. And yeah, so that is that. And I ask you this because my favorite thing, the thing that brings my heart joy, is the periodic table. I love the periodic table. It's like my favorite. It's the most awesomest thing in the world. There it is right there. I love the periodic table, ladies and gentlemen. I have my own personal one right here. It's the best thing ever. Love it. And my goal with this PowerPoint, or with this today, is to try and get you to maybe love your periodic table equally as much. So let's hope that we can do that together. Out of everything, Jaden, I choose the periodic table of elements. Look at this periodic table. Oh, I should put my light this down so you can see better. Look at it. It's beautiful. I really do love the periodic table. I'm a nerd. All right, so let's begin. It is important. Yes, Danielle. So let's begin with today's discussion. So in module 2, what we are talking about in module 2 is we're talking about the atom. So in module 1, we talked about how we have matter, and we talked about all the ways we measured it. And in our last one, we talked about our last lesson, we talked about how you have an atom and it has a nucleus and it has these electrons that are arranged in these shells, and how those electrons get excited, and basically how we create fireworks, how we create color from lighting up, from heating up elements. So today, what we're going to do is we're going to talk about the periodic table. And the periodic table talks to you or gives you this plethora of information that you can use to solve chemical reactions and all sorts of things. Like, seriously, I think after this lesson, you're going to like want to have a periodic table on you at all times. I totally agree. So here we have this beautiful periodic table here, which is something that you would see in a classroom. And the first thing that we want to ask ourselves is, how is the periodic table organized? So I'm going to talk today about how you can understand or read a periodic table. So the first thing is if you notice here, is that your periodic table is organized into groups and periods. And groups are the vertical columns, and periods are the horizontal columns. I have a really silly way of remembering this. I think of group, period. Get it? Like group, a row, period, a column. Or no, yeah. No, this is the column, this is the row. Group, period. That's how I remember it, because I think like when you're like, that's it, period. You know, you're like, period. So I go group, period. So in your non-video world, hopefully you are, just say it out loud in your house right now. Go group, period. I hope you did it. So that is how the periodic table is organized. It's organized into these groups and periods. And one thing I just want you to know about this is that the periods, these guys right here, is that they are numbered. So actually they're all numbered. This is numbered 1, 2, 3, 4, 5, 6, 7. Okay, so there are 7 periods. And I just want you to know, if you remember in the last lesson that we talked about how you have a nucleus, right? And how you have these shells around the nucleus, and how those shells have electrons in it, right? And we said that, you know, the electrons move up and down between the shells. Well, those shells are numbered 1, 2, 3, 4, and they go up to 7. So these numbers here, okay, each period represents a shell added on to an atom, okay? Isn't that cool? So you can like know that if you have an element right here, that there are 5 shells, energy shells, outside the nucleus. If you have an element here, you know that it has 2 shells outside the nucleus. So that's just something that will just rock your world and help you understand the basics of this, okay? Does everybody get that? Give me a thumbs up if you get that. And if you don't, good. Jaden, are you going to sleep? Not yet. Oh, crying. Okay, so, oh, I forgot one more thing. So the other thing that I want to say about this is so that the groups, the periods are numbered 1, 2, 3, 4, 5, and they reflect the shells, okay? Then you also have your groups numbered, and how your groups are numbered is they're numbered across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? So you have your periods, which are numbered, and they relate to the shells of an atom. Okay? And then you have your groups. With your groups, these guys are related to like just one shell, okay? And we'll talk more about the groups later. But the groups are basically, when we're going across like this, we're just adding electrons to a shell. Okay, so those are the numbers. Now what you're going to do is you are going to look at a periodic table. And we're just going to get familiar with the periodic table. So this quiz that you're going to take next is just to get familiar with the periodic table. And if you look here, it's going to ask you what is the symbol of the element that is in period for group 15. And then here's the periodic table to the right. This is a periodic table that's on my home page. So go ahead and go through. And this is just to get you familiar with the periodic table and just reading it. Okay, and if you have any questions while you're doing this, if you're like, don't understand, just text me on the chat and I'll respond to you, okay? And we will continue listening to some music while you answer these questions. Go! Is the music playing? There it is. You can dance while you do it. Group. Period. Group. Period. Period. Shells. In shells. Yes, you're doing good so far. Everyone's getting there. Good, good, good. Ooh, everybody knows how to read a periodic table. Awesome. Almost there. Yes. Awesome. Good. All right, everybody got them all right. Fantastic. Okay, so just to make sure, what is the symbol of the element that is in period 4, group 15? So all you do is you look at your periodic table. That's a bummer, it's showing up over here. All you do is you look at your periodic table here. Okay, and now I can't see it. So it is period 4, group 15. Period 4, group 15. And if you notice, it's all numbered, which is nice. So it's really easy. So it should be arsenic, okay? So the first one is B. All right, so I'm not going to go through it with the periodic table. I'm just going to go. The second one, what is the name of the element that is in period 2, group 2 on the periodic table? That is beryllium. Good job. And the third one, what is the name of the element that is in period 6, group 10? That is platinum, PT. I want to love you, P1T, pretty young thing. All right. So that is it for that part. So that's just to get you familiar with the periodic table and to make you understand that you can find the elements by looking at the groups and the periods, and that the periods represent the shells as they increase going away from the nucleus. So now the next thing I just want to mention, and we're not going to go too much into it, but I just want to make sure that you're aware, and that is when you're looking at the periodic table, that the elements are organized. It's called periodic table because there are periodic trends in them, and that's what you're going to be learning next, or that's what you will be learning this week along with this. So if you look on this periodic table, you'll see that the majority of your periodic table are metals, okay? And most of your metals are found here on the left side. And then you'll see that you have your nonmetals here. Those are your nonmetals, and there's not as many of them. And then you have hydrogen here, which is like the black sheep of the family. It's kind of like, it's over here on this side, but it's a nonmetal. And there's a reason for that, and it has to do with its electron configuration, which you should have learned about in 2.4. And it has to do with the fact of that it only has one electron. And if you don't know it, we're going to talk about it again later on. So in the middle here are your metalloids, and these are the guys that are like the in-between. And I wanted to show you this because sometimes I have students that, like, when we're doing a DBA, instead of using the periodic table I give them that's on the homepage, which is the one you really should use, they'll go and use their own. They'll find one on the internet. And sometimes these guys are different. The metalloids are different. It just depends on the periodic table. So I would strongly encourage that you use the periodic table that I give you on the homepage, because that's the one that's required with this course, and that's how they want you to know the elements. So this is how the periodic table is organized. Now, here we're getting into the juicy details. And the juicy details of this is that we determine an element by its number of protons. The number of protons determines an element. So if I tell you that an element has 6 protons, then I know that that element is carbon. So the protons, the number of protons, is the nameplate for the atom. It's how we know what element we're dealing with. No two elements have the same number of protons, and they don't get messed with. They do get messed with, but we're not going to talk about that now. That's like later, okay? So what we're going to talk about is how we can identify the elements, and the information we can get from the periodic table. So this is one box on the periodic table, and the first thing that you can get from it is you can get the chemical symbol, Au. So a lot of times, so this is this chemical symbol for gold, and I gave you this one because if you notice, it says gold, but the chemical symbol looks nothing like it. And so this is one of the things that you have to pay attention to when you're looking at a periodic table, is that sometimes the chemical symbol doesn't follow along with the name of it. Another one is potassium. Everybody thinks potassium is P, but it's not. Potassium is K. The one that's P is phosphorus. Okay, so you have to pay attention to that and just kind of be aware. If we were in a real classroom, I'd make you memorize all the chemical symbols, but we're not. So you just have to be aware that the chemical symbol doesn't always follow the name, as is the case here. Now, if you notice, there's two other things on this. You have this big number here, and then you have this decimal number here. So the 79, this number is called the atomic number. And this number is what identifies the element. This gives you the number of protons in an element. So I can look at the periodic table, and I can know immediately how many protons are in the element. So I know that gold has 79 protons in it. This is so important. You're out shopping with your family. You're at Macy's. Your mom is looking at a gold watch. You pull out your periodic table. You go like, hey, Mom, guess what? That element gold that you have that's in that watch, it's got 79 protons. If she heard you say that, she would probably buy you a car. I'm pretty sure of it. Okay? Trust me. So 79, so this number here is the atomic number, and it tells you the number of protons. Now here's the thing that everybody gets messed up on. Most people know that this gives you the number of protons, but most people don't know that the atomic number is equal to the number of electrons. So if you have 79 protons, you also have 79 electrons. So be aware of that the atomic number gives you the number of protons, but it also gives you the number of electrons, and they're equal. So 79 protons, 79 electrons. The other number that you have here is this number, which is the decimal number. If you notice, it has a decimal in it. And that's how you know it's different from the atomic number. This number is called the atomic mass. So you're going to start getting confused because you're going to have like atomic, atomic, atomic. And you'll be like, what? So atomic number is the number. Atomic mass has the decimal. Okay? And the atomic mass is the average mass of all the isotopes of the element. I'm going to talk about what an isotope is later, but just realize that the atomic mass is the average mass, and that's why it has a decimal. It's the average mass of the element. Okay, so this is what you see when you are looking on the periodic table, all the elements with their atomic number and atomic mass. Some periodic tables have other things on them too, but these are the major things you need on it: the chemical name, chemical symbol, atomic number, and atomic mass. So now what we're going to do is we're going to use this, and you are going to use your periodic table and interpret it with these questions next. Go, go, go! And we'll play some music. Pat Benatar is awesome. This lesson is like your first date with your periodic table. You're just getting to know it. You're just getting to know your periodic table. Be nice to it. Don't curse at it. Hello, periodic table. How you doing? Oh, this song is appropriate for getting to know you don't want your periodic table to be a heartbreaker. Remember, the atomic number is the number of protons. It also gives you the number of electrons. The atomic mass is the number with the decimal. So far, we're doing good. We've got some good first dates going on with our periodic table. Everybody did well on the first one, and you're doing well on this one. Yes. These are questions you are going to be asked on your DBA, and they will be important for what we do in the next section, too, in the next module. We're working our way to chemical bonding. Yes, I love that, too. Good job, Emily. Good job, Jaden. Yes. Do any of you have pictures of your parents with like super big hair? Your parents are probably my age. Did any of your parents have super big hair? You can chat it in the text if you'd like, or you can just give me a thumbs up if your mom had big hair. Or big earrings. Nobody? You're like, I don't look at my parents' pictures of when they were teenagers. Okay, Kayla, I'll go over it with you, okay? All right. Okay, so let's go over the question. So the first question is, what are the number of protons and electrons in an atom of oxygen? Okay, so instead of going between it, I'm just going to show the periodic table. And if you look here, there's oxygen, and it has an atomic number of 8. Okay, does everybody see that? You don't use the decimal number. The decimal number is the mass. The atomic number is the one that's solid, right? So, oh, hey, there's no right answer for number 1. I made a mistake. Kayla, good for you. You caught it. Why'd y'all pick C? Tell me why you guys picked C. Anybody? You didn't see 8, so you just picked C. Okay, it is 8. Oh my goodness. You guys gotta let me know when I make those mistakes. I make the mistakes. Good job, Kayla. Good for seeing that. So it is 8, and it should be 8 protons and 8 electrons. Yeah. Yeah, 6 was like the closest to it, right? That makes sense. Yeah, it was 8. My bad. Thank you. Sometimes I do these, and I'm so glad you caught that. Okay, so now we'll just put 6 on there, even though it's 8. Okay, so then the next one. Wait, was that it? that wasn't it. Hold on. Kidding. I went back. There's 4 questions here. I clicked the wrong thing. Okay, so we'll say 6 for that one. So the next one. So which element has an atomic mass of 87.62? You guys were all right. It is strontium, okay, which is right here. And you can see there it is, 87.62. And that is that the atomic number or the atomic mass? Somebody yell it out for me. Which one is it? Atomic number or atomic mass? Yay, everybody's just putting it in their message. Good job. All right, next one. What is this chemical symbol for potassium? So this was one of the ones to help you get familiar with that potassium is K, and the chemical symbol for potassium is K, which everybody got. Good. What is the name of the element that has the atomic number 29? And that is copper. And you can see it right there. There is copper, atomic number 29. Good job. All right, everybody. You did good on that. Yes. Now, I would like for you to answer an open-ended question. So I want you to look at the periodic table to the right. How would you explain to an 8-year-old a simple way to tell the difference between the atomic number and the atomic mass on the periodic table? How would you tell someone simply? Okay, so look at the periodic table, compare the atomic number and the atomic mass, and then simply tell me how you would remember or tell someone that. Okay? Tell it to me like I'm in kindergarten. Not like I'm in kindergarten. Let's say 8-year-old. Next song. Everybody likes this song. How can I find a woman like that? Good. All right. So I just want to share some of these answers because they're pretty good. So the first one is the atomic number is always on top of the symbol, but the atomic mass is always below it. What do you guys think about this answer? Give me, what do you think this answer? Do you think this answer could always be right? What could be a problem with this answer? Tell me in the chat box if you don't want to say it out loud. What could be a possible problem with this answer? There's a possible problem. What do you think it could be? Good, good, Danielle. So that's one of the problems with this is that obviously on our periodic table that worked, but on another periodic table, it could be different. So some periodic tables, it's not like above or below. Sometimes they do really weird things where they put the atomic mass on top and the atomic number on bottom. So although that is correct with our periodic table, that's not always the case. So what do you think about this next one here? Atomic mass are small numbers, atomic numbers are big numbers. What do you guys think about that one? Does that one work? Look at your periodic table. Is that pretty consistent? Give me a thumbs up or a thumbs down on what you think about that. Or you could just say yes or no in the chat box if you'd like. What do you guys think? Look at your periodic table. Does it work? It does. Actually, when I first saw this one, I was like, what? But then I looked at it, I'm like, oh, that's actually really good. So that's a really good one that I hadn't thought about, is that atomic mass numbers, except the only thing is I think he has them backwards. Okay, so let's look at this. Because he said atomic mass are small numbers, atomic numbers are big numbers. But if you look on the periodic table, our atomic mass numbers, the small numbers, the atomic mass numbers are the decimal numbers, and the atomic numbers are the non-decimal numbers. So what's the only problem with this? Who could tell me? I just realized that. What's the problem? It's backwards. Okay? So actually what it should be is, this is actually not a bad way to remember it, but the only thing is that it's backwards. And so it should be atomic mass are the big numbers and atomic number are the small numbers. Okay, so that is yeah, the decimal numbers are definitely bigger. Good. Okay, so that's another one. Okay, all right, and let's do good. Okay, and so then this one, the atomic number is the whole number above the element abbreviation. The atomic mass is the decimal. This is the most common way to remember it, and this is what pretty much everybody else said, except Jaden. 8-year-olds totally want to know this, Jaden. I just want you to know that. But this is the best way to remember it, is that the atomic number is the whole number, okay? And the atomic mass is the decimal. And that's the easiest way to remember. Although I will say that that last way was good. It just had to do it reverse, okay? All right, any questions on that? Give me a thumbs up if you've got it. And if you don't have it, just text me on the chat. Okay, we got it? We're good. Okay, so now we're going to talk about information that is not on the periodic table. So this is not on the periodic table, and this is a thing that confuses everybody because we've just talked about atomic number and we've talked about atomic mass, and now we're talking about mass number. Okay, so we have to clarify between these three. So let me just type over here once again, atomic number. Ooh, hey, that's not right. Let's type it right. Atomic number is the number of protons and the number of electrons, okay? Atomic mass is the weight, and it's usually a decimal, okay? So these are the things that we know so far, as we know these two things. All right, so now we're adding in mass number. And when we add in mass number, the mass number is the number of protons plus the number of neutrons. So the mass number is equal to the number of protons plus the number of neutrons, okay? And this is the thing about the mass number. It's not on the periodic table because it just varies. And this is where we have to talk about the word isotope. So you have all elements have this, say like an element has a specified number of protons. That element can not change its number of protons, but it can change its number of neutrons. And that is what an isotope is that you have elements and they have the same number of protons, but they have different number of neutrons. And neutrons, by the way, neutrons give the element mass. So when there's a lot of neutrons in the nucleus, that means that the element has a lot of mass to it. There's a lot of weight to it, okay? So here's an example of the most common example is carbon. Carbon has 3 isotopes, carbon-12, carbon-13, and carbon-14. So carbon has 6 protons, and if you notice, each one of these has 6 protons in it. But they're isotopes, and so the isotopes mean that they have different numbers of neutrons. So this one has 6 neutrons, this one has 7 neutrons, and this one has 8 neutrons. How do we show the mass number? So the mass number is not on the periodic table. It is not found on the periodic table. And so what we do is we can write it one or two ways. We can write it like this, chlorine 35, right? And this number here is the mass number. This is going to be the more common way that you see it. You can also write it like this, where you have the mass number on top and the atomic number on bottom. This is more convenient because then you don't have to use your periodic table. But typically, I don't see it this way well, we don't do it this way on the DBA, and I don't think you see this on your exam this way. I think they use this way more. You do need to be familiar with both ways because it just kind of depends on sometimes they change it up. But this number here is the mass number, and what it's telling you is it's telling you the number of protons plus the number of neutrons. And if you notice, so this is carbon 12, that's its mass number. So carbon 12, 6 protons, 6 neutrons. Carbon 13, it's always 6 protons, but now it's 7 neutrons. Carbon 14, 6 protons, but now you have 8 neutrons. And if you notice, the electrons stay the same. In each of these, you have 1, 2, 3, 4, 5, 6. So you have 6 electrons for each of them, okay? So that's the last thing to talk about is the mass number. So now let's do some practice with the mass number. Okay, and the periodic table is there for you with each one of these. So now you're going to be looking at mass number and figuring out number of protons, neutrons, and electrons. And if I make a mistake again, you let me know, because I make mistakes. Boy, let me tell you, I make mistakes. Woo! Another Pat Benatar song. Let's go to another song, although, oh, the Police. All right, get started. I remember the Police. Oh, the band, not the Police. As a teenager. I did get chased by the police when I was a teenager. Don't get chased by the police. Did I make a mistake on the first one? I should probably be checking my answers. Okay, I didn't. Do, 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 ba da, da, da. All right, we're going to need some help with this. Everybody always needs help with this. It's okay if you're getting them wrong. It's okay. It also might be I put the wrong answer in. And if you have any questions, feel free to ask me. Good. Give you a little bit more time. I know these take time. Like I said, this is why we're going over this. This is where a lot of students have problems. Okay. Okay. I'm going to go over the first one with you to help you guys out. Okay, so first one. So it says how many protons, neutrons, and electrons are found in BE9. So when we're looking at this, when you see the chemical symbol and then you see a number behind it like that, that means that this number is telling you the mass number. Okay? And the mass number is equal to the number of protons plus the number of neutrons. Now, you have to use your periodic table for this. And what you have to do is go on your periodic table and you have to find the atomic number. Okay? And so who can text me or who can chat or just say out loud, what's the atomic number for beryllium? Who knows the atomic number for beryllium? Good. Okay, the atomic number for beryllium is 4. And how we know that is we look on the periodic table and there's beryllium, Be, and it's 4. Okay, it's the big number. Remember, the atomic number is the non-decimal number. So the atomic number is 4. So that tells me that there are 4 protons and that there are 4 electrons. Okay, so we have now cut our answer down to these two right here. So it's either B or it's either D. Okay, do we see that? So then what we're going to do is we're going to take the mass number, and the mass number is 9, and we know our number of protons from the atomic number, and then we're going to figure out, okay, what's our number of neutrons? So we're going to subtract 4 from 9, which is 5, so the correct answer is D. Okay? All right. Does anyone have any questions on that? If you don't have any questions, give me a thumbs up. If you do have questions, put them in the chat or just say them. Okay, good. All right. Everybody else? Noah, Kayla, Jaden? Okay. I think Jaden's taking a nap. Okay. Next one. The next one. So, what are the number of protons, neutrons, and electrons in U-256? So once again, U-256. 256 is the mass number. Okay? So now we have to find the atomic number for U, which is uranium. Who can tell me the atomic number for uranium? Looking on the periodic table, what's the atomic number for uranium? Okay, you're right. It is 92. And so uranium is down here in the supercool area. So it's U, it's 92. So its atomic number is 92. And so 92 means it has 92 protons and 92 electrons. So that means it's between these. Oh, it can be this one too. It can be this one, it can be this one, or it can be this one. Who can tell me why it's not letter A off the cuff? Like just looking at letter A, why is it not letter A? Who can tell me why it's not letter A? You can either unmute yourself or text me. Okay, right. Neutrons shouldn't have a decimal, so that one's wrong. Okay, so it's not A. So it's between C and D. So how do we know? Well, the mass number is 256, okay? And you have your atomic number, which is 92 protons, and then you're figuring out your number of neutrons. So you subtract 92 from 256, and when you do that, you get 164, and so the correct answer is D. Okay, so are we getting that? Oh, you were just about to say that. Good, Jaden. Okay, got it? All right, now let's do the last one. The last one is the mass number of chlorine. What is the mass number if chlorine has 28 neutrons? So now we're going opposite here. So first of all, we have to figure out what is the atomic number of chlorine. So who can give me the atomic number of chlorine? What is the atomic number of chlorine? 17. Good. The atomic number of chlorine is 17. So it's asking for the mass number. So the mass number, if you remember, is the number of protons plus the number of neutrons. So it's asking you for the mass number. The atomic number is 17, which is the number of protons, okay? So we have 17, and then we have the number of neutrons. It's telling you the number of neutrons in the prompt. So that's 17 plus 28, okay? So 17 plus 28 is 45. And so the correct answer is B. And most of you picked C and D. Do you see now where you got that wrong? Give me a thumbs up. If you have questions, let me know. Okay, you see what you got wrong. Come on, give me feedback. I know we got to end soon. I know your brain's dying. Good. Okay, good. Kayla, you good? Kayla and Jaden? I want to make sure you don't have any questions on it. Okay. All right. So we're not going to do the next one. We're going to go on. And what I want to do first is I just want to review one thing, okay? And I just want to make sure that we're clear on this because, like I said, this is something that everybody always gets wrong. And I just want to make sure that you understand the difference between the three. Okay, so in summary, the difference between the three is atomic number. Atomic number is the number of protons, and it's what identifies the element, okay? It also gives you the number of electrons, okay? Atomic mass is the weight, or the mass, I should say, the mass of the element, okay? And it's typically a decimal number, all right? And this has to do with the isotopes. It has to do with the number of protons and the number of neutrons, okay? Mass number, okay, mass number is the number of protons plus the number of neutrons, okay? So these are the three major definitions that you need to know for this, okay? And you want to make sure that you have them clear. Atomic number, number of protons, what IDs the element, and you can also find the number of electrons from it. Atomic mass is a decimal number. It's the mass of the element, and it deals with the amount of isotopes. The mass number is the number of protons plus the number of neutrons, okay? Okay, so that's it. So now, oh, hey, what happened? What happened to my thing? Hold on. So now we're going to go to the collaboration board. Oh, that's right. Okay, I know why. And the collaboration board is going to tell you where to go. Huh, that's weird. It's waiting for teacher input, but I can't get on it. I wonder where it is. I don't know what happened to it. Okay. Jeez. Stop share. Let's see if we can find it. This happened last time too. Well, I had a collaboration board that was gonna tell you have any questions, comments, and concerns, but it's not showing up. So Nearpod is disobedient. Sometimes it just messes with you. So we'll just do it in the chat. So what I'd like for it, that's so sad because the picture was a picture of it saying, I love unicorns and periodic tables, which I love each of those. Okay, so what I'd like for you to do is in the chat, if you could please post for me, text me what you either got from this, what you still have questions on, or any comments or concerns that you still have, comments, questions, and concerns. I know you can't post memes, Jaden. I'm so sorry. Usually that's what we do, but this just didn't happen with this lesson. I guess I must have freaked out Nearpod by putting up the whiteboard. That's the first time I've done the whiteboard. Anyway, let me know your feedback. That is the end of the lesson. I hope this helped you. Please let me know in the chat questions, comments, or concerns. And I hope you guys have a great rest of your week. Please remember, you can always reach out to me for help. And yes, you can ask a question about the lab, Emily. We can totally do that. Good, good. So go ahead, and once you post a thing on the chat, please give me a post on the chat and any questions you have on the chat. And then if you're done, you can go. And it was very nice seeing you all here. Thank you all for being here. And have a good day. Good, good. Thank you.
Thank you, ma'am. Have a good day.
Thank you, Danielle. You too. All right, Emily, you want to hit me up with the question?
Yeah, so I'm looking at the lab right now, and I'm on the